In today's assignment, we will discuss points, lines, and planes. This is the first two sections of Chapter 1. Our essential question will be, what are the definitions of points, lines, and planes, and how are they related to one another? When you are watching a color television, you see an image that is composed of many different colors and are able to discern many different size images. In reality, that picture that you see is composed of dots of just three colors, red, green, and blue dots. You cannot see the dots because they are so small and your eye cannot distinguish them. However, the dot on a television screen could be considered in geometry to be a point. A point does not have any size. It has location, but it has no size. Normally, we're going to represent a point by showing it as a dot or an X on the board of your paper, okay? Now you can see two points represented by A and B. Again, notice that the points are red dots. The red dots do have size, but in reality, points have no size. But we have to be able to represent them, so we represent them by dots. There are actually an infinite number of points on the screen in front of you right now. I have only pointed out two of them. All geometric figures consist of points. Now, to take this a step further, the next geometric figure we want to talk about is a line. All right, now what you see on the screen is a representation of a line. Notice that a line extends in two directions without ending. That's the reason I've got the arrows on each end of the line. So it goes infinitely far in both directions. It has no width or thickness, but obviously when I draw it, I have to take and show some thickness or you wouldn't be able to see it. So the line extends infinitely far in both directions, but it has no thickness. Now we can identify the line by a lowercase letter, in this case M, so we could refer to this as line M. Now, if the line contains 2 points, in this case point X and point Y, we could also refer to this as line XY. Now, this can be written as XY with a line over it with arrowheads at both ends of the line. You could also refer to it as line YX. Either case, it's perfectly acceptable. Now, the last geometric figure we're going to talk about is a plane. Well, a plane can be suggested is much like the floor of a room, the ceiling, the wall, a tabletop, this screen that you're looking at right now. The only difference is, in geometry, a plane extends infinitely far in all directions. Well, we can't represent that effectively on a piece of paper, so what we end up doing is we picture a plane by drawing a four-sided figure. So the plane might be represented by this four-sided figure, and we identify it or label it with a capital letter, in this case P. So this would be plane P. So that now that we have described and explained what point, line, and plane are in geometry, they are used in the definitions of other terms that we're going to be running into throughout the year. So the first of these definitions is the definition for space. Space, and you could think of it in terms of outer space if you want, but it's also like the space in a room or anywhere. It's the set of all points. So it's three-dimensional and it's the set of all points. Collinear points are points all in one line. So as you can see in the figure, I have 4 points here, and I was a little off in drawing them, but they are all in that one red line, so they are considered to be collinear points. Now these blue points, however, are not in one line, and so they are considered to be non-collinear points. Now, coplanar points are points all in one plane. Now, if you've got points that are in multiple planes, then they are considered to be non-coplanar points. Now, the intersection of two figures is a set of points that are in both figures. For example, the intersection of these two lines is a point. It is, as you can see on the figure, labeled point O. Now imagine what the intersection would be of two planes. Imagine the wall in your bedroom and the ceiling in your bedroom. Where do they intersect? They are going to intersect in a line. Similarly, what would be the intersection of a line and a plane? A line that goes through a plane. And if you think about it, a line that goes through a plane, the intersection would be a point. So this concludes our discussion of sections 1 and 2 in chapter 1. Now I would like you to classify each of the following statements as true or false and post your answers in the Dropbox.